Very good morning to everyone. So, good morning to everyone. So, we have completed our syllabus. Means chapter number 7, the last chapter for the final examination. We have completed. Okay, so I have some question for you. Okay, for the series combination and parallel combination of the circuit. How to calculate the equivalent resistance for the series combination and for the parallel combination. Okay, let me know that if I give you a project for the series circuit, means you have to prepare a series circuit of the bulbs, 3 bulbs with battery and switch. How many of you can prepare? Just raise your hand. I want to know how many of you are interested. If I give you project to prepare, okay, very good. 2 students have raised their hands. And what for others? You can't prepare the project. I will tell you everything, how to prepare. You just have to, okay. Okay. And for rest of the students, and what for the rest of the student? You are not interested, means only 30-35% student raise their hand. And what for other students? You are not interested to prepare a project for the series circuit and parallel series circuit only. So okay, I will tell you what you have to do. But today today classes we will solve the numerical on the series combination and parallel combination of registers. Okay, so now you can put your hands down. I know. Okay, all of you just put your hands down. Okay, so okay, Prince and Abhinav, just put your hands down if you. Okay. Okay. First question and second question. Okay, so my question is that for the first circuit I have drawn, which combination is it? Series or parallel for the first? Okay, Sadhgi, Rishi, Kritika, and rest of the student you don't know. Okay, I will ask randomly to one of the student. Okay, Aditi Pandey, 7th D.
Yes, sir.
Okay, tell me for the first circuit.
Sir, series circuit.
First one. Okay. Okay, Ishika Raj, 7th E. Just unmute yourself and answer. Don't waste time. Okay, Sadhgi.
So the first one is a parallel circuit.
Hmm.
And as for the calculation, the answer is 10 upon 3.
Okay, And for the second one, which circuit?
Series circuit.
Okay, fine. So just put your hands down, student. So if you have gone through the solution, exercise solution, you have solved the exercise. So you know that this combination is parallel combination. Okay, parallel combination of the register, and this is series combination. Okay, so the first one is parallel. Okay, and the second one is series. Now you have to calculate the equivalent resistance. Okay, you can put your hands down. Okay, you can put your hands down, all of you. Very good. So you have to, yes, Ragini, just put your hands down. So you have to calculate the equivalent resistance. For the series, it is very easy. We have to simply add the two resistance, means R subscript S, means for series one, 6 ohm plus 9 ohm. That will be equal to 15 ohm. Okay. So for calculating the equivalent resistance for the series circuit is easy. Just add up. Okay, simple addition. 6 plus 9 is equals to 15 ohm. Now we have to calculate the equivalent resistance for the parallel circuit. So have a look here. So I told you for the formula for calculating equivalent resistance for parallel, R, and this is P for parallel circuit. 1 upon the first one, 5 ohm, 1 upon 5 upon 1 upon 10. Okay. Now 5 addition of fraction. First we take LCM of these two. Okay, Aditya, you have any doubt? Or
No.
you have calculated? Just raise your hand, Aditya. Okay, you have calculated the answer.
What, sir?
Have you calculated?
Yes, sir.
What is your answer?
The 3 upon 10.
3 upon 10. Okay. Mukund?
Yes, sir. The answer is 3 upon 10.
Okay. Okay, Ankita, your answer?
3 upon 10.
Okay, mute yourself. Usso?
Sir, 3 upon 10.
Okay, Hemlata? What is your answer? Okay, Yunus? Okay, we will solve. Now the LCM of 5 and 10 is 10. 5 to the 10, 2 1 2. 1. Okay. 3 upon 10. 1 upon RP. Now you forgot to reciprocate this. Okay. So now this is the value of 1 upon RP, and we have to calculate RP. So here RP equals to, means equivalent resistance for this parallel circuit is equals to 10 upon 3. Okay. So you have forgot to just reciprocate the last step. Okay. So the answer will be 10 upon 3, which will be equal to 3.33 ohm. Okay. Now I want to conclude one thing for the parallel circuit. Just solve one more question, then I will conclude. The first one is 3 ohm, 5 ohm, and 10 ohm. Okay. Now you have to calculate. Let's see who's going to calculate. We have to calculate the equivalent resistance for this parallel circuit. The given resistance for the first means R1 is equals to 3 ohm, R2 is equals to 5 ohm, and R3 is equals to 10 ohm. Just calculate it. Okay, Utso, you want to ask something? Abhinav? Okay, if you have no doubt, just put your hands down. Yes, Sadhgi, you want to ask something
Sir, I've got the answer.
for this one?
Yes, sir.
Your answer?
30 upon 19.
30 upon 19.
Yes.
Okay, we will check. Just mute yourself. Okay, Astitwa Pandey.
Sir, 30 upon 19.
Okay, Utsav.
Sir, 30 upon 19.
Okay. Vaibhav.
Yes, sir. Good morning, sir.
Good morning. Your answer same.
Yes, sir. 30 upon 90.
Okay. Okay, so we got so many answers for 30 upon 19. Okay, we will check here. Okay, you can put your hands down. So equivalent resistance for this parallel combination is equals to 1 upon 3 plus 1 upon 5 plus 1 upon 10. Okay, LCM of 3, 5, 10 is 30. 3, 10 times, 5, 6 times, 3 times. Okay, that will be equals to 10 plus 6, 16, 16 plus 3, 19. 19 upon 30. Now, 1 upon Rp is equals to 19 upon 30 and Rp is equals to 30 upon 19. Okay, that will be equal to less than 1.5. Okay, that is less than 1.5 ohm. Okay, so we can write approximate 1.4. I'm writing 1.4 ohm approximate. See, for the equivalent resistance, which when they are connected in parallel combination, okay, their equivalent resistance is always less than the smallest individual resistor, is always less than the smallest individual resistor. For the last question, we have calculated that there are two resistors, 5 ohm and 10 ohm, and connected in parallel combination. Their equivalent resistance comes 3.33. Okay, that is less than the smallest individual resistor. That is less than the smallest individual. Here, 3, 5, 10. So answer means equivalent is 1.4 ohm. That means it is less than the smallest, which is the smallest in all three, the three, and the equivalent is smallest, less than the smallest individual resistor. Okay, so this is the conclusion for the parallel combinations of the registers. Okay, now one more question. This is A, that is 10 ohm. This is B, that is 15 ohm, and this is C, which is equals to 5 ohm. Okay, don't solve, just tell me how to solve this circuit. First, what we have to do? Who's going to tell me? Anyone? What is the approach of this question? Okay, Sadhgi. Okay, tell me. Yes, Sadhgi. Okay, anyone else who's going to tell me how to start this question? Okay, anyone? It's not necessary you give the correct answer. Just try it and tell me which circuit is connected in parallel and which is a series. Okay, Rishi, very good. So tell me.
Sir, first we will solve the
Parallel series, not parallel combination. Okay.
parallel combination, and then we will add the series in it.
Okay, very good. Anyone else? Aditya?
Yes, sir. Same.
Same. Same means first you will solve this for the
Yes,
parallel
sir. And then
and
we
then
will add.
the equivalent you will add to the this one.
Yes.
A cell. Okay. Astitva,
Yes, sir. My also same.
same. Okay. So you have got the approach. So just start the question and solve it and tell me the answer. What we have to do? First, we have to solve these two registers, B and C, which is connected in parallel. So we will solve this 15 and 5 by the formula of parallel combination of circuits or registers. Then we will get the equivalent for this two. Then we will add this to A because A and this whole connected in series. Okay, you can put your hands down. Bavo, you
Yes,
got
sir,
the
I
answer?
got answer.
You got the answer?
So 55 upon 4.
Okay, Bavo, 55 by
4.
4. Okay. Sadgi, your answer?
Sir, 55 upon 4.
Okay. Rishi?
Sir, 55 upon 4.
Okay. Mukund?
Sir, 13.7.
13.7 means same thing. You have converted into decimal.
Yes, sir.
Okay. Okay. Utso?
Sir, 55 by 4 ohm.
Okay. So most of the students have got the answer. So we will solve and tally the answer, verify the answer. So first we will solve B and C, which is connected in parallel combination, connected in parallel. So for parallel, 1 upon Rp is equals to 1 upon 15 plus 1 upon 5. Okay. Now, LCM of 15 and 5 is 15. This will be 15 and this will be, sorry, this will be 1 and this will be 3. Okay. Now it is 4 upon 15. Value of 1 upon Rp. Now you can put your hands down. Okay. I got. Okay. So now value of Rp will be equals to reciprocity 15 upon 4. Okay. Yes, Aditya. Any doubt? Okay. Abhinav, you have any doubt? Okay.
No, sir.
Okay, Gauri. So don't raise your hand unnecessary. Okay. So for this combination, we got the equivalent resistance is 15 upon 4. Now, so we can draw this like this is 10 and this is 15 upon 4. Okay. Now we will add 10 plus 15 upon 4. 4 10 ja 40, 40 plus 15, 55. 55 by 4 ohm. Okay. That is the answer. Okay. Now, if I asked that, if I told you that this circuit is connected to 9-volt battery, 9-volt battery. So what will be the value of current? Calculate it. Or I can say 11-volt battery. 11-volt battery. So what will be the value of current? Calculate current. Connected to the 11-volt resistance, 11-volt battery, and resistance is 55 by 4. So you have to calculate the current. Okay. Now, okay. Mukund, what is your answer?
Sir, 4 by 5.
4 by 5. Your Sadhgi?
Sir, 5 upon 4.
5 upon 4. Okay. Utsav?
Sir, 4 by 5.
4 by 5. Aditya?
Sir, 4 by 5.
Shreya?
Sir, 4 by 5.
4 by 5. Okay. Just see here. B is equals to 11 volt. Okay, and equivalent resistance is equals to 55 by 4. And we know the formula V equals to IR, V voltage, I current, R resistance. So I is equals to V upon R. V equals to 11 and R equals to 55 upon 4. So this will multiply to the numerator. 11 into 4 upon 55. 11 1 times, 55 5 times. So the answer will be 4 by 5 with unit ampere. Okay. Yes. Abhinav, what happened? Okay. So your homework is to calculate the equivalent resistance and current for the given circuit. Five ohm, 3 ohm, 3, 4, 10 ohm, and connected to 9-volt battery. So you have to calculate equivalent resistance and the value of current. Okay. You don't need to draw, you can take a screenshot from your mobile. Okay. So for now, thank you. We will meet in the next class.